Good morning, or wherever you are in the world. Hopefully it is a, a good time of day for you. What we're going to do for the next hour or so is talking about microservices. My focus is on what microservices are and how they integrate into your organization. I've left some time for questions, so if you have them, please ask them. As Paul said, it might be a moment before I can actually respond to them, but I will respond to everything that comes by. So mostly, though, what I'll be doing is talking about what microservices are, what their characteristics are, how they fit into your organization. This is really the beginning of what is normally a very, very long class. It takes, almost a day just to get through the basics of what microservices are and how to program them, how to build effective ones. There are a lot of details. So we're not going to obviously cover those details in an hour, but we can at least get an overview of what we're looking at. Now, what we're looking at right now is murmuration of starlings. And the reason I like to start with this picture is that this is not a bad picture of what a huge system of microservices would look like. Is that microservices are the individual birds in this cloud. They are single, small things that have some intelligence, that do some work, but they interact with the things around them to produce this large, organized system that does way more than any one piece can do. So there are a lot of characteristics of this flocking behavior that you actually see in microservices. And the picture really demonstrates both the advantages and disadvantages of microservices as a system. Is that they're robust. If you were to run an airplane through the middle of this cloud, that would disperse for a moment and then come back together and start working again. But at the same time, it's very complicated, and it's very hard at runtime to understand exactly what's going on inside the system. So I'll have more to say about that in a moment, but just bear in mind then, when we're talking about microservices, we're talking about a collection of independent things that are interacting with each other, and that the sum of those interactions is a much larger thing than the individual pieces of it are. So the other thing I'll say by way of preliminaries is that obviously I'm not going to cover everything there needs to be covered in an hour. So if you want to go on and do some reading, I can strongly recommend Sam Newman's book, Building Microservices. Sam doesn't, again, get into code, but he talks a lot about the nitty-gritty details of implementing a microservice, is what the problems are and what the general solutions are. So this is a pretty good book to follow on this session. So the first point I want to make about microservices is that these are not typical service-oriented architecture systems. Often when people think about microservices, they think about them as if they are little web applications, as if a microservice system is a collection of 40 or 50 very small web applications that talk to each other over HTTP. And that just simply is not true. We won't have time to get into all of the details as to why that won't work. But a microservice system is a functioning computer program when you look at it in the whole, which is to say it's much better to think of them as objects in an object-oriented system defined by classes than it is to think of them as web applications. You may use web technology like HTTP to implement a microservice, but that's really a superficial kind of thing. It's a small implementation decision. And in fact, using web technology for the services is not the best implementation decision. There are better technologies for implementing them that address their flaws and strengths a little bit better than any kind of web system would. So a microservice is not, then, just a small web application. What is it? Well, let's start by talking about the monolith. Is that all of us have dealt with a monolith at some point or another. And in fact, generally speaking, when I teach a microservice class, the people that are in it are people that are working with a monolith right now, and they just can't stand it anymore. Is that it's just in the way of being able to make progress. Monolith, of course, is one giant program that does everything, and they have lots of problems. First of all, and from a design point of view, this is probably the most important thing. The monoliths are not typically very well organized. Now, they can be. It's possible to have a well-organized monolith. And in fact, microservices at the design level rely a lot on a technique called domain-driven design, DDD. And domain-driven design was invented originally as a way of beating a monolith into shape, of making it tractable, if you will. So monoliths don't have to be bad, but the vast majority of them are. The vast majority of them have been around for a long time. They've grown gradually, and in the process of doing that, they've lost pretty much all of their internal structure, to the point where all that often people understand about them is the API at the very edge of the monolith that's used to talk to it. And once you get into the monolith itself, it's just a mass of unmaintainable code that nobody can understand. Other issues, they tend to access data, as I'll talk about this in a moment, but microservices are focused on doing work, not accessing data. Data is a part of what they have to, let's see how to say this. All microservices obviously have to have underlying data in order to do their work, but the microservice systems are not data focused in the way that monoliths are. There is no central database that is used by all of the microservices, for example. The monolith is very hard to update. There's lots and lots of internal dependencies. You make a change in one corner, and suddenly you find yourself having to make changes in lots of corners all over the place. And that obviously is suboptimal if your goal is to be agile, for example, because you simply can't change them fast enough to be viable in an agile environment. They're very hard to deploy. You've got to deploy the whole thing, for one thing. And a deployment process for monolith can take days. It's difficult to deploy them in the sense that often you need to deploy a new version because there has been a very small change. And if you have a monolithic system, you can't do that, particularly if you're working in an agile environment. I'm a pretty hardcore agile guy, so I'm always working in an agile environment. Agile is all about making small changes and getting them into our users' hands as quickly as possible. And those changes can be released very frequently. If you look at Amazon, which uses a very microservice-like system, they're releasing changes into the actual running application about once every 20 seconds. So if your monolith takes 2 days to deploy, you certainly can't be working in a flexible, agile environment where you need to deploy quickly. Because of all of this, they are extremely hard to maintain. And probably the biggest problem with maintenance is the accretion of garbage, is that people add things to the monolith in order to solve problems that are in front of them, but nobody ever seems to take things away. So if you look at most of the existing large monoliths that are out there, most of the code that comprises the monolith is not used for anything. So all of this together means that agility is basically impossible. If you're trying to work in an agile environment, fighting your monolith will make it impossible to be agile, simply because you can't release changes fast enough, and any change that you need to make takes too long. So obviously that's not going to work. So the other biggest problem with the monolith is pretty much every node in the monolith is potentially a single point of failure, which means that one small thing can go wrong in one corner of the monolith, and that thing will stop the entire monolith from functioning. So with microservices, we're trying to solve that problem by taking our monolith and breaking it up. The basic idea here is that the microservice system is a system of independent objects, if you will, for lack of a better word, each of which does a small part of the work that has to be done in order to get work done, in order to get the larger job done. We'll look at the characteristics of these individual pieces in a moment, but just looking at this picture, this of course doesn't look at all like a monolith, and that's important. Each of these squares, each of these microservices is an independent thing. It can scale independently. You can replicate them. And in fact, that's how microservice systems scale at runtime, is you scale you accommodate additional volume, for example, at runtime by duplicating microservices so that several of them will be running in parallel rather than having to do things in series. They're working on a network, which is a big deal because communication across the network is inherently unreliable. And unlike a monolith where you're just making function calls, the equivalent of making a function call in a microservice system is very difficult. And if you think back about our murmuration of starlings a few minutes ago, these things have to be deployed and tested in very different ways than they would be if they were a monolith. You're deploying them individually. You can test them individually, but testing the system is something that almost always has to happen post-deployment at runtime. In other words, microservice systems, the final tests are actually done on the deployed system as it's running. I can't talk about that a lot in an hour, but Netflix is a great example of a large microservice system that is tested dynamically as it is actually running. And it's something that you just have to do, but it's very different than what we're used to when we're thinking about monolithic systems. Now, the next issue with restructuring our architecture in this way is Conway's law. Conway's law used to be rather obscure, but it's been coming out more and more in talks about things like agility and microservices lately. I've put the URL of Conway's original paper down there at the bottom of the slide if you want to read it. It's worth reading. But what Conway's law says is that the structure of an organization is directly reflected in the structure of the systems that the organization produces. In other words, the way in which your organization is physically organized is what kind of groups it has, what kind of teams it has, how the teams interact with each other, how the organization is structured, for lack of a better word, is always reflected in the code that you write. So let's look a little bit about exactly what I mean by that. In a monolithic system that is an n-tiered system, typically you'll have groups that are focused on the individual tiers, and those groups are independent, or they're independent of each other. Let's put it that way. Is that there might be a DBA group, some business specialists, some UI guys. They will have groups of them of their own, right? There will be a UI group, there will be a business group, there will be a DBA group, a database group, there will be others, right? Testing groups and that kind of stuff. But they are largely independent from one another. Now, what that means is that people inside any of these groups can talk to each other much more easily than they can talk between groups. As a consequence, the people that are working on the equivalent parts of the system are going to want to constrain communication as much as possible with the other parts of the system, or the people working on the other parts of the system, because communication is hard. In other words, when you have a business organized, as I've shown you on the left, you end up with a program organized like I showed you on the right, where the program is modularized into individual chunks, each of which maps one-to-one to an organizational structure. And it's communication that does that, is that this way the DBAs can work on the database layer without having to talk to many other people. And the business guys can work on the middleware layer without having to talk to the database people or the UI people much. And the UI people, by the same token, can do their own work and not have to talk too much outside of that group. So the social structure of the organization is mapped into the architecture. When we move into the microservice world, the structure of the organization has to change to support that. Every microservice is effectively a standalone program. Every microservice has its own database. Every microservice has its own business logic. Every microservice has its own user interface. So as a consequence, if you had separate teams in charge of the database and the business logic and the user interface trying to work together on one microservice, they would be stepping on each other's toes all the time. You can't get work done. So what you have to do in order to build microservices effectively is create teams that have all the skills on them that you need to build the service. In the Agile world, we call these cross-functional teams. And in fact, going to microservices sort of pushes you in the direction of a very agile structure inside the organization itself. But the main point I'm trying to make here is that microservices go way beyond simple architectural choices. You are not just redesigning your existing system, because if the structure of the organization doesn't change in a way that will support the new architecture is simply not going to work. It's going to take too long to build. It's going to take too long to maintain. In fact, it will be unmaintainable, and it just won't work. So my point here is that this process of moving to microservices involves way more than just a simple architectural change. Now, the issue here then is that Conway's law is going in both directions. As Conway says that the structure of the organization controls the structure of the code, but the other direction is that if you change the structure of the code, the structure of the organization has to change in order to go along with that. So What exactly is a microservice then? Let's delve a little bit deeper into what the characteristics of the individual microservices are. The first one is that they're small. And by small, I mean really small. The general rule of thumb that people use when they describe small is that a microservice should be no bigger than your head. And what they mean by that is that you ought to be able to have in your head at once the entire service. You understand what all the code is like. You understand the business side of the service. You don't have to look things up in order to understand anything. You don't have to talk to anybody in order to understand anything. You can keep the whole service inside your head. In practice, if you're a programmer, you can think of a microservice as being class-sized. A typical microservice might have, I don't know, anywhere up to 500, 600 lines of code in it, but not a lot more than that. They tend not to get up into the thousands or hundreds, certainly not hundreds of thousands, but they tend to not even get into the thousands of lines of code in terms of size. I'll say as an aside here, by the way, that often when people are starting out with monoliths and trying to break them up into smaller systems, you can't actually break the monolith up into true microservices. You just can't get small enough. And that's fine, right? There's actually nothing wrong with that, because even if these are macro services, if you will, big services, you still will be in a better place than you were when you had a monolith. But a true microservice is very small. It's easy to maintain because it is so small. It's easy to deal with generally because it's so small. All of the problems associated with complexity go away. The next characteristic of a microservice, and in a way this is the most important one, is that microservices are independently deployable. And in fact, you could argue that if you do not need independent deployability, there is no reason to be using microservices at all. Microservices carry with them a lot of runtime complexity that you don't have in a monolithic situation, and a well-structured monolith shouldn't be too hard to maintain. So the point here is that the independent deployability allows you to deploy individual microservices as individuals without impacting the rest of the running system. So if you need to make a small change, that change might impact one or two microservices. They're only a few hundred lines long, so they're not hard to change. And as soon as you change them, you can immediately deploy them into the system, and the system will absorb the new versions without a hiccup. So that is the whole point of having a microservice system, in order to get that independent deployability. As I said, if you're not going to use it, then there's almost no reason to go to microservices. The next important characteristic is that the implementation details are hidden inside the service. Or to put it another way, the microservice has a well-defined API that other systems use to talk to it, but you don't really need to know how a microservice works in order to use the service. Now, there are a lot of design issues here that, again, we can't talk about in an hour, but one of the problems that you see with people that are used to old-style SOA kind of thinking is they think about the server-side piece as being a wrapper around a database where you're just getting data and setting data through a well-defined API. Microservices do not work that way, because accessing the database is an implementation detail. So as a consequence, you'll never be accessing, typically you'll never, but usually you do not access any of the data that the service uses to get its work done. Instead, you ask the service to do some kind of work for you. And how it does that work should be unknown. Now, one of the things that gives you, which is important, is that you can then make changes into how the service does its work without impacting any of the users of the microservice. So the fact that implementation details are hidden is one of the things that gives you independent deployability. If you don't hide the information, if you don't hide the implementation rather, if you deployed one microservice, you might have to deploy 15 others because they're all leveraging something about how the one you just actually changed works. By hiding the implementation details, you do not have that problem. Microservices are always really modeled around business concepts. So that's actually another very important aspect of the services. When you learn more about them and start going into how to design them, they're designed collaboratively with business people. The structure of the system models the business almost directly, as the names of the modules map to business units, the The service is divided in the same way that the business is divided. The communication that goes on within the service, between services rather, as they run, will mirror the communication that happens inside the business as the business is working. So there are a lot of advantages to that. The most important one being that if you're in an agile world, the changes that happen change in the business. So if the microservice system is a model of the business, when a business level change happens, it's very easy to find where in the code you have to change in order to accommodate the new requirement. They are always decentralized, which means they're distributed across a network. And a lot of the complexity of implementing a microservice has to do with that decentralization, has to do with the fact that you are dealing with network calls every time you're talking to another service. And services talk to other services all the time. So as a consequence, not only are they distributed, but they tend to be reactive. They tend to be based on messaging. There's a lot of technology that underlies a well-designed microservice system that you will not find in a typical web application. So there is a learning curve here. You have to learn about things like messaging if you're not using it. A lot of the things that you do know about things like HTTP will not apply in a microservice world. It's a very different way of approaching program structure in general, the notion of decentralization. And this is a big deal, is that it changes pretty much everything about the way you think about the interaction between the components in your system. They have to be highly observable as a consequence, because if you have a bunch of decentralized things running on a network, if something goes wrong, it's hard to figure out what went wrong unless the services themselves help. So you have to be able to not only monitor the services from centralized dashboards and that sort of thing, but logging is a very important part of implementing microservices. Is they have to tell you when things go wrong. Otherwise, you're just up the creek if you find problems in your system and they need to be fixed because you don't know where the problem is. And then finally, they have to be autonomous in the sense they are highly isolated from each other. Or to put it another way, if a microservice fails, the rest of the system will continue to function. So they are very, very robust. They have to be very robust. The whole system, in other words, is very robust. Again, thinking about that cloud of starlings we were looking at way back at the beginning of this talk, if one of the birds gets tired and drops out of the flock, it's not going to impact the behavior of the flock as a whole at all. So microservice systems work the same way, and it's the autonomy that does that. And the autonomy is really autonomy. They really, really, really have to be standalone, independent things that don't depend on anything else to be able to do whatever it is they do. Now, that's not to say that the system as a whole doesn't depend on multiple services all functioning, but the individual services should not depend on other services in order to work. That's of course, a rule of thumb, not a law, is that sometimes there are dependencies between services that are inevitable, but you've got to minimize that as much as possible. And you have to minimize it both in terms of temporal, time-based things. Microservices typically cannot assume that certain operations will occur in a certain time sequence, and they have to be location transparent in the sense that microservices cannot assume that a given microservice is at a particular place, for example, in the same data center that it is located in. So the autonomy of the services is perhaps the most important thing. It's a small, independent thing floating alone in a space like this, and it doesn't depend a lot on any surrounding context. It has to be completely self-supporting. So, for example, if you need to deploy a service in order to run another service, then it's probably not a microservice because there is a dependency relationship there, which is in the way of getting things to work properly, is that it is you just don't want those dependencies, in other words. You don't want to have to deploy one in order to deploy another. And again, I'm not talking about the system as a whole here. Of course, for the system to work, multiple microservices have to be all up and running and functioning. But the individual service should not depend on another service for it to work. The other issue, which is extremely important, is that the microservices have to be platform independent. In other words, if you have a distributed system and it's distributed across multiple data centers, then you can't depend on a specific platform being present at the place where you distribute it. Put it another way, I don't have a slide to this effect, but just off the cuff, if you look at the SLA for something like Microsoft Azure or Amazon AWS, your uptime is not guaranteed to be 100%. It's never 100%. And if you actually sit down and do the math with the percentages they give you, 99.998 or whatever it is, you'll find that they are not guaranteeing that the system will not only not be up all the time, but they are guaranteeing that it will be down a percentage of the time. And a single Amazon virtual machine, for example, is almost guaranteed to be down at least 20 to 30 minutes a year. And if your system has to be fully functional without any glitches all the time, 24/7, it's risky for your microservice system to be hosted in one vendor's cloud. Netflix found this out a few years ago, if you could remember back, when Netflix itself went down for almost 2 hours or 3 hours because they were centralized in an AWS data center, and the AWS data center went down. So in order to get maximum reliability, you have to have your services be completely platform independent. And among other things, that means that we cannot be leveraging a lot of the things that many of the vendors want us to leverage in order to lock us into their platform. Lock-in is a big deal. Microservice people stay awake at night worrying about being locked into specific vendors. It's not an accident if you look at most microservices systems to see that they're built primarily on open source software. It's because the lock-in thing really scares people. The other issue with microservices is they have to follow what's called the single responsibility principle. Now, a lot of people don't understand what single responsibility is. They say a service has to do one thing, and that's not strictly speaking true. What we're looking at now is the opposite of single responsibility, though, is that this knife, I guess you could call it a knife. It's getting kind of big to be a knife, but certainly too big to put in a pocket. But this knife does not do one thing. It has a plethora of tools, some of which do things that have no relationship at all to what some of the other tools do. Certainly the fingernail clipper has no relationship at all to the pair of pliers which is next to it. At least we hope that they don't. The same with a compass, right? This compass has nothing to do with sawing wood, which is the tool that's a few down from our compass tool. So the point here is that this is a kind of catch-all mess where we have a single thing that does everything under the planet. Now, a microservice is better demonstrated with a tool like this, a corkscrew. Well, it's not really a corkscrew. This is a wine bottle opener. So it is concentrated on doing one thing, which is to say opening a bottle of wine. That's what it does. And the idea here is that it has on it all of the tools that it needs to do to be able to handle that one responsibility, that notion of opening the bottle of wine. So as a consequence, if you go to open a bottle of wine, you grab the one tool and you're done. You don't need anything else, but there is more than one tool here. Single responsibility doesn't mean it only does one thing. It means it does all of the things that it needs to do to handle whatever its responsibility is. So microservices all have single responsibilities. That's the other kind of key characteristic of all microservices. They focus on being responsible for one operation inside of a larger set of operations, and they delegate to other services to handle other operations that might be involved in the same task. Microservices then don't fit into a lot of the things that the vendors wish that they fit into. Here's an example of, well, not example, but this is a picture of Microsoft's Service Fabric. And the reason I'm bringing it up is that Microsoft pushes the Service Fabric as a place to host your microservices. And in fact, it can do that. But truth to tell, the Service Fabric is really a monolith into which you are plugging services. It is not a standalone thing. And the services that you plug into it must be written in a way that supports the fabric. You are not only locked into Microsoft as a vendor if you use it, but you're really locked into the Service Fabric also if you use it. So the Service Fabric is not really aligned with microservice thinking, is the idea that all of the services would have to be locked into a common underlying platform in order to function is just kind of flies in the face of what microservices do and how they work. So when you see things like this, I would approach them with some skepticism. There are certainly companies out there that are such hardcore Microsoft shops that they don't mind being locked in. That's fine. But if you do that, just bear in mind that there are downstream problems that you're going to encounter that are going to be, well, there'll be problems. Is that it's better to not lock yourself into specific technologies. All right, now, the next thing I want to do is I want to talk a little bit about how microservices work. This is kind of the one sort of more technical thing that I want to talk about in this particular class. Microservices talk to each other typically by not using something called orchestration. I want to start with orchestration because when people think about microservices, one of the first things that they think about is orchestrated systems, because they are thinking of the services as if they are small web services talking to each other across some API built using something like HTTP. In other words, if you're thinking about microservices as a set of synchronous services, and they don't have to be synchronous, I should say, is that this kind of orchestrated system could have some parallelism going on inside it. But often, when you have an orchestrated system, the services are working synchronously with respect to each other. And notice that they are not temporally isolated here, in the sense that the shopping cart service, if you look at the flow of control, talks to the billing service, and then it talks to the warehousing service, and then it talks to the email service in a specific order. And sometimes that ordering is important. It can't talk to one until it talks to the other. So in this case, ordering is temporally connected to the warehouse in the sense that the system won't even talk to the warehouse if the billing service isn't working. There are a bunch of problems associated with this system, though. The first one is the coupling relationships between the services, even in this very simple system. The shopping cart service, for example, has to know that the billing service API has an issue invoice method on it in order to be able to work. So if I needed to change that issue invoice API, adding arguments, for example, or maybe making it a two-step process when it's now a single-step process, I have to also change the shopping cart service in order to be able to handle the changes in the billing service. And this is a bad thing. For one thing, it damages our independent deployability principle, is that the billing service cannot change without having to redeploy it and also redeploy a changed shopping cart service that's designed to accept the new billing service. We also have a bunch of other issues associated with the multiple versioning. Is the writing a shopping cart service to handle all versions of the billing service will be difficult. So if you have a requirement that every instance of the billing service has to be brought down and replaced with instances of the new billing service, and the shopping cart service has to be brought down in order to support it, by the time you're done with all this, you might as well have a monolith. Is you have to bring so many services down and then back up again that you've completely lost the advantage of being able to deploy them independently. Now, the other issue, which is an important one, is what happens if something goes wrong on the network. Remember, these are not function calls. We like to think of them as function calls, but they are not function calls. These are individual services in various clouds scattered across the network. And at any point, something could go wrong, as one of those network connections could break. Well, what do you do in that situation? Well, you can call the billing service, but the shopping cart service can't get to the warehouse service. It might try multiple times, but eventually it might just give up. So we have a big problem here with consistency. The billing service as a microservice will have its own database. It will be keeping track of its own data, and it will think, in fact, it may have actually build a client. So the invoice has been issued. The billing service has done whatever it needs to get billing in process, but because we couldn't talk to the warehousing service, the item that the client has bought is not being shipped, and that's a big deal. Now, recovering from this can be difficult. If the billing service, for example, has sent out invoices, physical invoices in the mail, recovering from a broken warehouse service is not easy. If it's an online system, of course, it's easier. We can just send an email out to our customers saying, I'm sorry we lied. We're not actually going to send this to you. Amazon does that occasionally, by the way. But generally speaking, recovering from this error is a very difficult thing to do. When you start learning about microservices that are built in this kind of declarative way, using an orchestrated system, there are a lot of design patterns and so forth that you'll learn about, things like circuit breakers and bulkheads, that are designed specifically to be handling errors that occur in this kind of synchronous or at least orchestrated environment. But those things add a lot of complexity to your code. And even if you're working with something like the Spring framework, which Spring Boot handles some of the overhead of recovering from situations like this for you, it still adds complexity to your code. It makes it harder to maintain, it makes it harder to write. And generally speaking, it's gonna cause problems. So microservice systems then tend to be what are called choreographed systems. Let's take a moment and look at those. So here we have a set of synchronous services that are talking to each other the same way they were before. In order to choreograph them, we are going to make this change. So these are now asynchronous services. I should have added an A up at the top of that slide there, in the sense that the billing service, the warehouse service, the email, and the shopping cart services are all running at the same time, but completely independently from one another. When the shopping cart service gets an order, it passes it sends order placed messages, if you will, to all of the other services, the downstream services that might be interested. We think of this in terms of events. It will issue an event, which is then received by all of the downstream services. This is called reactive programming. Good microservice systems are almost always built so that the vast majority of interactions between services happen in this way, is that the services are very, very loosely coupled from each other. In other words, if the shopping cart service just issues an event that says an order has been placed, if you're interested in it, deal with it, the shopping cart service doesn't even know that the billing, warehouse, and email services exist. So unlike the situation in our orchestrated system, if I deploy a new billing service, the shopping cart service just doesn't care. Is that the billing service, the new billing service might handle that order has been issued event differently than the old billing service did, but the shopping cart service doesn't know that or care about it. So we have a much, much, much more easily maintained system here because of the reduction of coupling relationships between the microservices or between the individual microservices, let's put it that way. So the basic idea here then is that reactive systems are at the center of how microservices work. And one of the things that you have to do as you learn about building microservices is learn how to build reactive systems. There are some practical advantages as well. If you look at the first system, the order-based system, the latency between a request and a response is the sum of the time required for all of the orchestrated services to do their work. If you look at a reactive system where everything is happening in parallel, the time it takes to go from the request to the response is just the worst case time for any of the one services. So there's a lot of parallelism going on in here, and there's a lot of event processing going on in here. So you want to be using technologies that are good at event processing, publish, subscribe in particular. For example, microservice systems are almost all built on top of messaging systems like ZeroMQ or RabbitMQ, or Kafka lately has become popular. And these are all systems that are designed to support publish, subscribe event models, and that's not an accident. So the notion of you're just going to write a bunch of little web services and we're going to have APIs defined by HTTP, that's just not true. That's not the way that microservices work, at least not good ones. The main issue is that REST is effectively a synchronous protocol. And what we're talking about here is highly asynchronous systems. And trying to force REST to work in an asynchronous way is more trouble than it's worth. It's just something that you're not going to do when you're dealing with microservices. So that is an introduction, and that's the basics or the basis of what microservices are and how they work. I left us about 15 minutes to answer questions and so forth. So I would really appreciate it if you guys would answer questions, as I'm here and I can answer any question that you want that's been brought up by any of the things that I've been talking about. So here's one. What would you choose as a secure and practical way to communicate between microservices to ensure their interdependence? The services that I build are all built on top of a messaging system of some sort. So the one I'm using right now is a messaging system called ZeroMQ. The advantage of ZeroMQ is that it's actually, I can, since we're sharing the screen here, I'm going to get rid of this nice slide. I'm sorry about that. And I'm going to bring up an editor window just so I can write in a way that you guys can see what we're doing here. That way I can give you some notes. Let's get this big enough so that everybody can see it. All right, so the system I'm using is called ZeroMQ. And the advantage of Zero is that it is a highly performant system. It was designed, it's very, very lightweight. The entire set of APIs in ZeroMQ is, maybe there's 20 APIs that you need to learn in order to use it. And in fact, on a day-to-day basis, you would need to use even fewer than that. So it's very fast, it's very simple, it's very easy to use. It doesn't require any kind of elaborate configuration. It's a great system. There are a lot of microservices systems built on top of Zero. If you weren't using Zero, you might use Rabbit. MQ. The Rabbit supports a messaging protocol called AMQP. Is the reason I bring that up is that existing messaging systems inside a large corporate environment probably support the AMQP protocol. So if you're using something like Rabbit, what that means is that you can talk to existing parts of your existing system over your existing messaging layer, even if your existing messaging layer is not using Rabbit. AMQP is that the messages can span systems quite easily. The third one that people are using now is Kafka. Kafka is entirely a publish, subscribe, event model way of messaging. So in fact, if you're trying to use something other than events, it's kind of tricky to do that in Kafka. So as a consequence, a lot of people like to go to Kafka because it is so event focused. It's slower than Zero. It is more complicated than Zero to set up. There's more configuration. There is centralized configuration. Zero is a completely distributed system. There is no centralized broker in ZeroMQ. Kafka does have a centralized broker, which means you've got to worry about clustering and that sort of thing in order to be able to use it. On the other hand, it does a better job probably than Zero in handling a large volume of messages going between various services in such a way that services can join and leave the network more easily without losing messages. That's the main advantage that Kafka has. So you see them in both situations. So another question popped up. What's the difference between a web service and a microservice? Well, a web service it's a small program that either includes an HTTP server or is sitting behind one that receives requests using HTTP one way or another. It's accepting a post request, for example, and it provides a response. That's one way to do a microservice, but it's very difficult to get orchestrated systems or to get choreographed systems if that's the way you're organizing things. So a web service is a service that's based on HTTP, running on the web, using a well-defined API, typically a REST API, typically passing information around using XML or JSON. Microservices do not have to use HTTP at all. If they're based on top of a messaging system, there's no point in the microservice using HTTP, for example. So as a consequence, it's a very different thing. Is that message-based systems are much more lightweight. They're much faster. They don't have anything like the overhead of a web service does. You're not dealing with HTTP at all unless you want to. And generally speaking, they're better for back-end processing. Remember, microservice systems, the system as a whole, is meant to do back-end processing. The other big difference that's worth mentioning is that typically, if you're talking web services, you're talking about APIs into a monolith. And with a microservice, it's not one thing. It's 100 things, or 200 things, or 500 things, all of which each have their own API, which is exposed to the web. So you have all of the problems associated with that. The attack surface is very large if you're interested in security, which we all should be. But the point is that the structure is very, very different than what you would expect. See another question. Would you consider a governance structure or microservice library to keep the services clean? That's a really interesting question. Generally speaking, no, I wouldn't, at least not in the formal sense. Libraries, shared libraries in a microservice world, I'll get back to my question mark thing here. Shared libraries in a microservice world are problematic. The problem is that if you have two microservices that are sharing a common library and a change is made in that library, you have to recompile and redeploy both of the microservices. If the library is shared by all of the microservices and you make a change to that library, then you have to recompile and redeploy the entire system of microservices. And the whole point of microservices is to not have to do that. In other words, if we're deploying the whole system, we may as well just make it a monolith and get it over with. So generally speaking, this notion of normalization with respect to code, that we should have shared libraries as much as possible and we should be all leveraging those shared libraries, is kind of a suspect notion in the microservice world. The feeling is that it's better to have replication and not have to redeploy than it is to have no replication and coupled deployments. So that's not always going to be the case. If the library is very stable, if it's not going to change much, then sure, go ahead and use it. We're all using libraries that are not going to change. If we're using Spring, for example, you don't expect it to change much. But even with something like Spring, if there's an update to Spring and some of the services depend on a new version of the Spring and some depend on an old version of Spring, the fact that you shared a library means that there's going to be a deployment problem when it comes time to deploy. So you're not trying to do this with governance. You're trying to solve the problem by independence, by making the services as autonomous from each other as they possibly can be. How do you begin the challenge for learning how to become a microservices guru? Where do you start? Well, you can start by taking a class, right? My strong advice. I don't want to sound self-serving here, but when I do a microservice class, it takes, well, depending on how you do it, but it takes a day at least just to learn the basics. And when I do microservices classes, I almost always like to have workshops associated with it so that people can get some hands-on experience doing some or learning, learning how to put things together. There is sort of a core set of skills that you're going to need. I should have left my editor up here. There's a core set of skills that you're going to need. Microservices are designed around something called domain-driven design, usually, or DDD. So you should learn something about domain-driven design. There's a really good book on it there's a book called Domain-Driven Design Distilled by Ron Vernon, which is very good. I recommend it. The original domain-driven design book was written by Eric Evans. Eric's book is a little long, but it's and a little dense, but it's a good way to get started. So take a class in domain-driven design, learn about messaging. That's really central. But really, it's a matter of learning how to do it, and a lot of this stuff is not written down. So here's the place to start, at least, though. If there are no microservices in the organization at all, frankly, I would start by bringing in an agile consultant. It's one of the things that I've done several times, and it's important because microservices and agile go together. We talked about Conway's Law back at the beginning of the class, The point is that if you're going to microservices, it is going to require structural changes within the organization itself, at least within the engineering department. So you've got to start that process by talking to the people who are in charge of that sort of thing, the upper management. They have to get involved. This is not just an engineering decision, in other words. Distributed applications is a hot term these days. Is this different than microservices? If so, how? Well, it's one of those terms that's kind of fuzzy. So it is different in the sense that there are many ways to distribute applications that do not involve microservices. So, for example, this notion of serverless, Amazon Lambdas, for example, as an example of serverless, is a situation where you have a remote database living inside the Amazon cloud, and then you break down individual functions, really. Amazon Lambda is a single function which exists as a standalone service inside the cloud. This is a way to do distribution, but this is not a microservice. So there's lots of ways to have distributed systems that are not microservice focused. I think microservices are the best compromise between the problems that you have with highly distributed systems and the problems that you have when with keeping a coherent application together. So that's the direction I would go if I was going in the direction of distributed. But you don't have to do microservices to do distribution. Distributed applications don't necessarily use HTTP, though often they do. At least that's the way people think about them. But they can talk to each other in other ways. Is that messaging, again, is a great way for distributed components to talk to one another. Messaging is one of those things that's been around for an awfully long time, and it people sort of ignored it for years, and microservices have made the subject very, very relevant again. So a lot of distributed web services were HTTP based just because people couldn't imagine other alternatives. They didn't know about things like messaging. Nowadays, that situation is changing. So HTTP is easy, but it has a lot of problems. The performance being one of them, and just the overall structure of the deployed systems being one of them. There are microservice systems that are based entirely on HTTP, and they've got issues. They've got real issues. They are hard to maintain, they're hard to build, and they're not very fast. And one of the downsides of microservices in general is that, of course, you're going to lose some performance because of the fact that everything is distributed across the network. But you don't want to make it even worse than necessary. And using a technology like HTTP is going to make that worse. Fault isolation. So the point of fault isolation, that was the next question. Can you describe what fault isolation means? Fault isolation means that when something goes wrong in one part of the system, that failure is not going to influence the rest of the system. So if you think about the choreographed system that we were looking at a few minutes ago, the basic idea here is that, remember that the order processing service didn't know anything about the downstream services that were doing the processing. That's a fault isolated system. If the billing service went down, or if the warehouse service went down, none of the other services that comprise that system would be impacted by it. And of course, in order for things to work, when the warehousing or the billing service or whatever comes back up again, it has to start working again. So mixed in with this notion is also that notion of messaging that I've been talking about. So if our warehousing service went down for a couple minutes and it came back up, if you're using something like Kafka as your messaging system, when the warehousing system comes back up, it will be able to handle all of the events that were issued when it was down and not paying attention. So here we have true fault isolation in the sense that we could have a fault inside the warehousing system that caused it to crash. And the rest of the system would continue to function as if nothing had gone wrong. And then later on, the system that crashed could be rebooted, and then it could catch up. And the net effect being that it's as if it hadn't crashed at all. That's one of the things that makes it hard to implement microservice systems, but it's also one of the things that makes them so desirable, that they are very, very robust. As things can go wrong, and you can fix those things, and nobody notices. So it's an important part of any microservice system. Is there a best type of organization or system to move from a monolith to microservices? Well, I'm an agile guy, so of course I'm going to say that yes, agile organizations are the best type. I'm going to say that with some reservation, though, is that if you're into the agile community right now, you will find that almost all of the original agile people, people like Bob Martin and people like Martin Fowler and people like Ron Jeffries, like the signers of the Agile Manifesto, are very distressed by the state of the agile community. In general, I would hazard that 80 to 90% of the companies that imagine that they're doing agile are not. What they're doing is something that's just superficially agile, is that people have been calling it dark agile lately, or agile in name only, or a faux agile. They're going through the motions, but they're not agile in any real sense. So truly agile companies are by far the best kinds of organizations to move to microservices. And by truly agile companies, I mean companies where the teams are autonomous teams that are fully self-contained, they are truly cross-functional, they are not told what to do by anybody, rather they are given strategic business directives, and it's up to the team to figure out how to implement that strategy. I could go on. In fact, I do go on. There's an agile class that I do all the time, and I do a lot of agile consulting. But the point is that a true agile organization is not just doing Scrum. It's doing a lot more. But those are by far the best organizations that are suited for doing microservice kinds of things. So can you do microservices if your organization is not agile? Absolutely. It'll just take a little longer. The main issue is the Conway's Law issue again. So there are some things that you have to do to restructure the non-agile organization so it can handle the needs of building microservices. It's very difficult to build microservices, for example, if you have a QA department which is separate from the engineering department, and within engineering you have a database group which is separate from everybody else, because it just takes too long. So the organization, though, doesn't need to be agile in the sense that it can accommodate changes very rapidly, right? That's what makes an agile organization agile, is that a change comes in and you can deploy that change very, very quickly to your end users. Non-agile organizations cannot do that, but there's nothing at all that says that a non-agile organization can't be structured in such a way that it can do microservices quite effectively. You could also, this is a microservice class, but I should say that a monolith could be structured internally to look an awful lot like a bunch of microservices. So if you learn microservices, even if you don't implement them as microservices, even if you implement them as a monolith, that's actually a useful architecture. So the structure of a microservice system can be modeled inside a monolith pretty well, and you don't need quite so much agility if you're going to do that. Is microservices 100% top-down? Yes. It's very hard for it to bubble up, because it's very difficult for a system to microservice systems are systems, let's put it that way. It's possible for a corner of a system to be implemented using microservices while the rest of it is not, but it's very difficult. It's much better to move to microservices in a organized fashion that involves moving the entire system across. A lot of people, sometimes the advice I give when I see people's existing code is that they've got to rewrite it. And that's always met with horror, that statement. But bear in mind that Facebook and Twitter and Microsoft and Salesforce and just about everybody has completely rewritten their core systems at least one time. Spotify. Facebook's been rewritten twice. Spotify's been rewritten twice. Twitter's been rewritten 3 times. The point is that rewriting the system is sometimes the most cost-effective way to do it. And if you're moving to microservices, it's something to think about. You have to do it in an orderly fashion, of course, but it's something to think about. You can move incrementally, but if you're trying to do an incremental move from a monolith into microservices, typically you will hit a brick wall where you just can't move anymore. You can get so far, you can get to big macro services, if you will, but you just can't get all the way down to the microservice level because of the impediments of just trying to do it incrementally. So that's going to involve everybody from the top down. There's really no way to do it. It's very difficult to do from the bottom up.
We are Starweaver. Education you can bank on. For more information, contact us.